This is a video about the task sheet for our PSMT. And this is really just to boost or reinforce what we've already been over in class. We have looked at the task sheet in the classroom, but in case you've forgotten something or want to hear it again, you've got this video. So please take note of the important things. Perhaps you might like to have your task sheet out while you watch this video, or just take your usual Cornell notes. On the front page of our PSMT, we've got the basic core information, and we'll scroll down past that to resources available here, and we can see that technology is required. So when we say technology, it could be things like scientific calculator, graphics calculator if you've got access, but you might not, and that's okay. Spreadsheets, Excel may come in handy. Mathematical software, a big one for this assignment, you probably already know based on the other videos, is Desmos, or Desmos as some people say. The context, now this is something here that you consider. You have to basically accept that the context is true, okay? And we see the tide times and heights can be predicted accurately for both short and long-term time intervals. So for something that's fairly close to now, or something a longer way into the future. Of course, there may be limits to that. Graphs of tide fluctuations have some resemblance to trig functions. So the rise and fall of tides, maybe it can be modelled with trigonometric functions, especially sine and cos. So let's have a look. Now down at the task, this is what you've got to do in general to investigate. Now the word investigate is a rich word, and in our math subjects, investigate's got a specific meaning. It basically links to the 4 steps of the problem solving process. So investigate is basically the combination of the processes on the next page. So we've got formulate, solve, we have evaluate and verify, and of course all throughout the whole time we're communicating. So we've got communicate there. Okay, so that's investigate is a combination of all of those things. So the stuff that links to what we've been doing in class and the videos are here. Now that doesn't imply an order. You may be using technology before you look at your parameters A, B, C and D. You know from the videos that we've been using Desmos and Excel and perhaps other things as well, but we've also learned about A, B, C and D. They affect the shape of the graph, and we can modify those, or we can refine our models. We can come up with a model and refine it, and we can transform the graph using the parameters A, B, C and D. So it links to our work on transformations, which we have already completed to a certain degree, and depending on when you're watching this video, perhaps there's more to come too. The 4-step problem solving process, you've seen this before because it's introduced in year 7 at our school, and so we've got the 4 stages. These are actually aligned extremely closely to the QCAA, the Queensland Curriculum and Assessment Authority, and basically they run all the senior and junior assessment, and in senior in particular this will be on all of your PSMTs, problem solving and modelling tasks, so we're training you to get used to it. Okay, so formulate is the first step there, and basically when we formulate we have to basically clarify what the problem is asking. So in the understand section there, we need to clarify, what does it want me to do? What information is important? Could I express what we have to do in my own words? What information do I have? What information do I need to calculate or research? Okay, so that's all involved in here, and that's part of designing a plan in order to solve the problem. So it's how do we get to the point where we can solve it. So hopefully you've had a read of this part here and you've got your task sheet, or you can pause the video to have a closer read. But in this particular assessment, what we need to do is you need to use some research, find an appropriate data set, and then graph that data set. For example, graph it with a scatter plot, which is basically, as you know, it's a bunch of dots, using technology like Desmos, for example, maybe Excel, and all of that again is on the videos, and use regression to come up with a reference graph. So a reference graph is using technology to find a starting point. It's a good starting point, and it gives you something to aim for as well. Okay, so it's something to aim for, depending on how effective the technology is. Regression has been covered in a different video. And of course in this work we're doing trigonometric regression. Here on page 4 we can see that same formulate criterion. Basically page 2 tells you what to do, or in general what things we should see, and this page tells you how well to do it, and that's how rubrics and criteria work. So you can see in order to aim for the top marks, there's certain characteristics your work must have. You can see up the top too, it's got assessment objectives, and for this criteria it's these 3 here that are assessed, that are valued. So we've got selection, recall and use of facts, procedures and so on. We've got comprehend the math concepts and techniques from our lessons and videos, and justify your decisions by mathematical reasoning. So that might be in paragraph form in a report like this, because this is a mathematical report, and that's an important genre in senior. But it's also the your mathematical working. So you'll need, just like in your regular classes, you'll need at times to break into vertical working with equal signs and symbols and all the regular stuff there, formulas, numbers subbed in, all those normal things. So to get a 3 or a 4 you need to be demonstrating these. So for example, what does this relevant observations mean for our assignment? Well, it's to do with the finding the data set and showing it in your work. If it's a long data set, you might want to put it in an appendix and say see appendix 1 or something along those lines. But if it's not a huge data set, a table of data, you can put it in the body of your report. Also, you'd put in your initial graph too, that we were just discussing a minute ago using technology. So the initial graph, and basically that starting point from regression, which we just mentioned a moment ago. You're always able to rewind the video if you need another look at that part. In this section too, you also, it's a bit like an introduction, so you talk about the by hand methods that we're going to use in the solve part. So it relates to transformations. Alright, you'll talk about, we'll be using transformations and other things like that, calculations, etc., etc. So you discuss what mathematical concepts and techniques will be used when we get to the solve section. So you introduce them there. Of course you don't do it there, you do that in the solve section. So assumptions is a word you've no doubt heard in maths before, and the things that we take to be true in order to be able to get started. Things that aren't definite, but you got to make things we take to be reasonably. So you got within reason. You don't want to make any crazy assumptions, but things we take to be true within reason. So things we take to be true. Okay, so assumptions with tides. Perhaps if you don't know much about tides, you might need to do a little bit of lightweight research about what assumptions could be there. So assumptions can affect the calculations. Assumptions have effects, and they can change calculations depending on what assumptions you make. They may change the type of maths in some assignments, but if you assume something, it does have some sort of effect. So you might want to briefly mention that in the first section. Now, solve is where we move from, obviously, from what we didn't formulate. And solve is where we start to use by hand methods. So by hand means you need setting out. So it relates to A, B, C and D, the parameters, and how they work in trig graphs such as y equals sine x or y equals cosine x. And by hand means that it doesn't literally mean you have to use pencil and paper. It can be typed, however. You can do it fully digitally, but it is basically all the reasoning in that usual vertical working. So you need to show calculations and mathematical working there. Okay, because you can't let technology do the whole assignment for you. You can get a basis or a base point with technology, but you have to show your understanding by solving it by hand. That's how we measure your understanding. So that's the whole point of the assignment, isn't it? So it is not done fully with technology. Technology will give you a starting point back up here and formulate, but you'll need to do the regular working, and that'll be found in videos, and you may have already watched the video at this stage depending on when you view this one. You'll notice the words synthesizing and refining. Now that's really important, because when you solve something, is it solved or is it at a really good stage? So you have to think about that. The idea of refining is coming up with a start and then seeing if you can improve it, modify it in order to make it better. Synthesizing is creating a model. So you'll get in something like this, A times sine bx plus c, for example. You'll synthesize a model, and you need to do that by finding the values of A, B, C and D from the plotted data. Okay, so from the plotted data, from the data you get from your research, okay, the data with hands-on methods will then be able to help you synthesize. Alright, we'll create an equation, and that's basically written here. Create a trig function that fits the chosen data. Explain your processes. That means show working just like you would on an exam or in class. Okay, so you need to show your working. Even though it's a report, there'll be mathematical working in there. Full working will get you better marks. Then once you've got your trig function with A, B, C and D in it, you plot that. So that's generate the function using technology, and then you see whether it suits the data. Now that's what links us on to the next section, but before we do that, how well do you have to do solve? How well we do solve is here, and again we're looking at select, recall and use facts, definitions, procedures, and it's about problem solving process as well. So if we have a look, in solve is worth the most marks, okay, because it's got all the basic maths in it, so all the essential maths. So of course it's got the biggest weighting out of all the sections. So what you need to show, we might look at the top two levels there. So you need to use technology. Now if you use technology in a meaningful way, it'll contribute there, but if you use it accurately and appropriately and thoroughly, and you can demonstrate that, that contributes up there. If you apply maths concepts that are relevant to the trig we're doing, you might get contribution there, but if you do something more discerning and more high level using better applications, that will contribute up there. Discerning means that you understand what you're choosing to use, and you understand it well, and you can demonstrate that. And accurate use of complex procedures. Now you've got to use, to get in these top two, you need to use complex procedures. So if you use something simple, it'll only contribute down that way at most. So complex means we're after something thorough. Now if it's thorough and it comes up for a reasonable solution, you'll get a contribution here, but if it's accurate and complex procedures, it comes up with a strong and valid solution, it'll contribute up there. Next is evaluate and verify. So once you've got a possible solution, okay, you need to consider how reasonable it is and how useful it is in terms of solving the given problem, which is on page 1. So you think, oh, now what did we have to do? Has this done the job? How well has it done the job? So that's evaluating your results. So basically you need to explore the good points and the bad points, or the strengths and limitations of your solution or your model, and you might need to go back through your process to further refine, like I was saying before, and that's here. If it's not that great, you need to go back and try again. Now if you have a reasonable solution but you go to improve it, maybe keep the old reasonable solution, and I want to see the story of how you've refined it. Okay, I want to see the ongoing story of how you refine your work, improve it. That's what engineers do. They use an iterative method, and that means going through a loop of continual improvement. And I want to see some of that, because you get credit for that. So, and make sure it's valid for the real world. Okay, so does your tide match the real data, yes or no? And explain, have you done the best job you can? If you have, well, then the model, you might come to the conclusion that trig models are okay at modeling tides for whichever part of the world you've chosen. However, there are limitations, and maybe you might say the model's good for this part of the world, but it's no good for some other part of the world. So tides are different for every little location. So you might want to do a bit of background reading about that, perhaps, if you don't know much about tides. And you need to demonstrate the use of your created function in making short and long-term predictions. Okay, so you can get the 2000, if you're watching this in 2019, if you're watching this in the future, well, just put in whatever year this is that you're watching it. But basically, they've already calculated all the tides for the rest of 2019, and you can check yours against that by extending the domain of your function and appropriately doing calculations to show. So with calculations, so there are calculations in this section as well. So whether you use substitution or solving. If you put future values into your equation, does it match the true or predicted values from a government website, for example? Okay, and that's what it means by verify for real times and heights, and discuss the suitability. So again, we'll be seeing things like substitution, algebraic substitution there. For evaluate and verify, basically to get the top marks, you need to justify decisions at all stages using mathematical reasoning. So that's formulas, but also other reasons explained perhaps in sentence form as well. Formulas do a lot of work with the justification. Or explaining your steps is another way of putting that. Explaining your steps, whether it's a formula or with a sentence. Documentation of strengths and limitations of your solution. Is it valid at anywhere, at any time? Okay, where and when, I guess, are key things. Is it valid? Where and when? Valid means does it work? Where, when? There'll be limits to that, but what are the pluses? Don't forget about the pluses. We know no mathematical model is perfect, but you discuss how it's useful. Evaluate the reasonableness of solutions by considering the results, assumptions and observations. So again, like we said, has it worked? Is it reasonable? And do the results make sense? Does it give good predictions? Does it give good predictions? Because that's one of the keys to this PSMT, is ability to make predictions. Lastly, we have communicate, and communicate is sort of spread throughout the whole assignment. So the development of solutions and models, whether it's the abstract or the real world communication, you'll have both. Abstract is the purely mathematical part, which will be in your working, and then you need to translate that to the real world. What do those numbers mean in the real world, if they have a meaning? So we value clear and full communication and mathematical working. So it says that they're concise, which means complete and clear, mathematical, but also sometimes everyday language as well. Make sure you draw a conclusion at the end. Your final paragraph is a conclusion about how, and refer back to the central question for that, how well has your model and your work basically addressed the central question of the assignment. And you know, it's interesting to see when students speculate and offer further explanations or justifications, and even some recommendations. That might be something to consider. So communication is all throughout this work. And lastly, these are the characteristics. All right, you know, your mathematical and everyday language. What's it going to be? What's going to give you the big marks for it? So make sure you use coherent and concise. So coherent means you make sure an audience can understand what you mean. Some students can be very vague, and you need to be specific about certain words. And you should know from our lessons the vocabulary. You may need to go back through your Cornell notes or the videos again, or your textbook, but you need to use the vocabulary. Don't be afraid of it. It's there to be used, and it helps this coherence, and it helps you be concise, which means you don't waffle. Every sentence and every statement mathematically has a purpose. Remember to write in a report genre, so introduction, body, and conclusion. You need to make sure that it is readable without having to go back to the task sheet. That's a good strategy to see if it's readable without looking at the task sheet. Can it be understood by someone with a reasonable